Sorry, guys, we had some technical issues, but now we are ready for today's workshop. So welcome to the day 3 of Digital Futures and LookX workshop. Today I will talk about two main topics. First, I will introduce an amazing open source Stable Diffusion software, which is the Stable Diffusion Web UI. Some of you might have already installed it. If you haven't, don't worry. I will show how to work with it, and you may install it and try later. For the second part, I will dive deeper into some basic concepts and knowledge for evaluating a LoRa model. So let's get started, please. This is the very basic Stable Diffusion Web UI. It's an open source user interface based on the Gradual library for Stable Diffusion. So Stable Diffusion is basically just a safe tensor file, so you need a user interface to interact with. These particular UI user interface provides you with a user-friendly graphical interface for interacting with your models. And it is developed by Automatic 1111. It has over 90,000 stars on GitHub now. Basically, it has four main features. It is the text to image, image to image, in-paint, and upscale, corresponding to four of the main ways that user want to use it. Text to image is the key features. It allows user to generate images from text, also called prompt. You just put in some prompts and negative prompts to generate your desired image. And image to image generates image based on the base image. Basically, it's an image that you put as a reference. The generation process will start from the base image and towards the prompt. And in-paint will let you create a mask in the image and generate new images that only the mask area will be changed. So you can see that here I created a mask on the sky and created a spaceship, some kind of UFO on the sky. And upscale can usually be used to bring a lower resolution image to a high-res image. There's another very important feature called ControlNet. It enables image generation in a more controlled way. For example, we have a sketch of a building. I can use it as a input image and use a preprocessor, which is a built-in feature of the ControlNet feature. It would process the image into something like the image in the middle with white sketch and black background. And these pre-processed image will be added to the diffusing process, which is the image generation process, so that the generated images will have the same structure as the reference image. So we could see that from the image on the right is following the main structure of our sketch. Another reason why Stable Diffusion Web UI is very popular is that it has extensions. So it's a collaborative development process. A lot of users wants to add different add-on to web UI so that they could use it for different purposes. So it's very easy to access these extensions from web UI, and you could just they even have a tab for you to load it. We will talk about it later. A very inspiring extension for Stable Diffusion Web UI is the Depth Map extension. It enables you to create a depth map animation generated by one image. So basically, you just put an image in that extension, and there's an algorithm to extract the depth map of that image and create a zoom in video for it. So with some editing and After Effects, you could get something like this for better visualization. You can see that it's basically a 2D image, but we managed to get some additional visualize effect for that. Web UI, Stable Diffusion Web UI has another important feature, which is the API, which enables developers to get access to some of the wrapped function provided by Stable Diffusion Web UI. For example, for those who are not familiar with API, it is something that developers get access to some wrap function. For example, if we have an API that do the square numbers and a function for calculating square numbers, I could basically send a request, maybe a number 6, and the API will return a 36 to me, which is the result after calling that function. You don't need much knowledge to use an API. Some basic Python experience and a ChatGPT would basically do the job. Stable Diffusion Web UI provides lots of different API for external requests. So here we have the text to image API, and of course you have also the image to image and upscale or other stuffs. So by using this web UI, you can develop your own development, your software development for in your own application using the functions of web UI. So before we go into the next step, I will show something about the Stable Diffusion Web UI, so you could see how it works. So this is the very pure Stable Diffusion Web UI. I don't have much extensions installed. So we can see that it has some tabs on the on here, including text to image, image to image, and some other stuffs which are not quite frequently used. So for text to image, it's very easy. So if you tap in a residential building, for example, it doesn't matter if you have typos or something, because the text decoder would fix that for you. So you have a generated image, and you can see that there's a lot of parameters that you could tune in the interface. And by hovering your mouse here, you could see what it is about. For example, the sampling method, it says it's the algorithm to produce the image. For more specifically, it's the diffuser that you are going to use. And for the sampling steps, it's the how many iterations that you want to diffuse your image, and some other important parameters such as aspect ratio, the width and the height of the image. Usually we use a multiplier of 8 or something for width or height. So that's for the pixel. The number is for the pixel, and also you can change the batch size. So if I change the batch size to a larger number, then I can generate multiple images at a time. So for the image-to-image is a very important thing. So I would like to load in a image and try to. All right, let's just. Why don't I just use one of these to generate? So I can just send this image to image, and then change some of the prompt to different environments. And also remember that for image to image, we have very important parameters called the denoising strengths. It determines how strong you want this image to change. So basically, the larger number this is, the more your image would change. So if I set this denoising strengths to a lower number, then you could see that it is changed to the direction of my prompt, but not as much as the one with higher denoising strengths. And though I don't think it's changed at all. Anyway, so this is something that you will have to try to get it work, to get a desired result. Okay, so now we have the sunset environments and also the original layout of the image. As for the InPaint, I can just send this image to InPaint, where I can directly draw a mask here. Maybe I don't want these trees, or so I just create a mask for it. And I just say, sky, for example. And there's a lot of parameters here, but not all of them has something to do with this process. Let me see. All right, it's changed a bit, but not very much. I should try to change the denoising strengths. All right, you see the trees are gone, even though the skies are not consistent. But yeah, I would try these parameters. All right, it's nothing better. So don't worry. It could be a perfect match if I get the prompt and the denoising strings right. So now you can see it's better. So that's for the in paint. And also you can send this image to Extra, where you can scale upscale the image to a higher resolution by using one of these upscale algorithms. These are some models that is trained with a lot of images, and each of them has a better effect for different purpose. For example, some of them are made for animations, some of them are made for general stuffs. So here I will use the 4X Ultra Sharp, which is very popular, and I will try to upscale it by maybe 2. All right, 2.05 is okay. So basically, it would keep everything of your original image, but tries to make it sharper so that it adds some details to the image so that it has higher resolution if you compare to the original one that we created here. Maybe it's not very apparent, but for some better demo, it would have a better result. Another important stuff is the control net that we said before. So here I would try to right. It's hard. So let me just use this image as a base. So you can see that the first thing it do is that it pre-process this image into some mediate image. For example, this the edges of the content of the image. This is the Kenny, which is an algorithm to automatically extract lines or tiny lines in the image. And we have also the depths. So it estimates the depth map of this image. So you can see that it has the outline of the building and the trees or something, but it's not very precise. And I won't go into detail of all of them, but we have also the the segmentation. So it uses a semantic segmentation algorithm to predict the semantic of different part of this image. Like it tells where is the building, where is the sky and trees and roads and something. All right, so I would just use this control net to create something new. Maybe I would just create a pyramid from it. All right, something is wrong. I didn't enable this, so let's do it again. So you could see that the generated image has very similar structure of the original one. Like for the part where it should be the sky, it is still the sky, even though the color is a little bit skewed. The trees, the roads, and the pyramids that we wanted, but even though it's not reasonable, it's fine. There's another very important thing about web UI is this stuff. It is called info text. Basically, it describes how the image is created. So if you copy this info text to here, and then you click this button, it would automatically parse that the info text and apply all the information to these parameters. It is very useful, and a lot of people didn't know it. So that's it. And there's the delete, which enables you to delete the prompts and the presets. And there's another important tab here, which enables you to load a LoRa model into this. So let's use a sorry, there's too many of them and they are not named properly. So all right, I would just, what's wrong? Okay, it's loaded. So basically, it just add something to the prompt so that you can call the LoRa. So the format is that a bracket and a LoRa and the name of the LoRa and the weight. And for LoRa, you usually need to know its trigger word. Basically, it's a prompt to activate the LoRa. I don't know the trigger word of this one, so I don't know if I can do it wrong, right? So maybe I could use something else for it. Yeah, let me just search for and. All right, this one I know. So let's see. Tap again to close that menu. All right, we could see that it's more like a handmade model, but also I have the ControlNet enabled, so this it's generating something like the previous image. But if we cancel that, we get something not really like it, not really like a handmade model, but we could change the weight of the LoRa to test whether it works. So this one is more like what we desired. So that's for the LoRa. And there's another thing here. The script is very important. The XYZ plot, which enables you to run a batch of generations at once with different parameters. For example, this, no, not CSV scale. Prompt search or replace or switch and replace. I don't know what it means, but it's okay. So I could start with some values like this. I intend to see if we use different weights of this LoRa, what will the generations, what will be the difference of the generation? So even though I have a batch count of 1, it would generate a lot of images based on these values. So it searched the first part of this text and replace it with each of them. So we see that with this LoRa, if we have 0 weight, it's generating the original base model prompt, and if that's 0.4, it's a little bit different, and 0.8 is changed further, and going beyond 1.2 would become something more and more handmade model. And for a very high weight, such as 2.0, it's going to be something obscure. So we don't want it to happen. So we should always keep the weight to a proper range. So that's it for now for the Stable Diffusion Web UI part. And we would go back to the concept. So for the second part, I would talk about LoRa evaluation. So some of you may have tried to create a LoRa with LookX Cloud AI. So you may be a little bit familiar with what a LoRa is and how to create one. But to begin with this topic, I will have a quick recap about the concept of checkpoint and LoRa's. So a checkpoint is or a model. So basically, we have some confusing terms for describing a checkpoint or LoRa's. Sometimes we just call them both models. But you should remember that a checkpoint is a larger model, which is usually 2 to 8 gigabytes. And a LoRa is a much smaller one, usually from some megabytes to 200 or 300 megabytes. Even though Stable Diffusion is great, but it's not good at everything. For example, that you could see that from the left-hand side is a residential building generated with original Stable Diffusion 1.5 You couldn't even tell it's a building. It's some maybe it's a building, but it's too abstract. But with a fine-tuned model, a fine-tuned checkpoint like exclude anything beta, we got a decent residential building, which is recognizable and have better lighting conditions and more details. So Stable Diffusion is great, but it cannot handle everything. So instead of trying to exhaust the capability of Stable Diffusion with prompt engineering and other stuffs, everybody can fine tune a model with some training images of a specific domain, such as architecture. Today, we have thousands of different open source checkpoints out there, focusing on different purposes, such as animation, realistic photos, product design, and etc. So a lot of people are working to make Stable Diffusion better for specific use. And here is just a case of architecture. I really like this image and borrowed it from another lecturer to talk about LoRa's. So LoRa models are much smaller to the checkpoint models for modifying styles. So basically, it's not going to change the basic attributes of the checkpoints, but it would move the generation to a certain direction. Typically, they are like between 10 to 300 megabytes, and you must use them with a checkpoint model. So a cheeseburger is maybe basically a checkpoint, and LoRa is the like bacon and pickles that you added to it. Some of you tried with LogX, and the LoRa models give more space for customization to users to reach their end goals. And you can even combine different LoRa's for your creation. So why LoRa if we already have checkpoints? Checkpoints are supposed to have the power to generate all kinds of images it has been trained on, or at least fine-tuned models. So for example, our architectural model should handle all the stuffs for a specific domain, right? But why do we need LoRa's? So why can't we just train all of the images into a big checkpoint to get what we want? To get this question, to answer this question, we have to dive deeper into how a checkpoint is trained. So for this one, you should view from right to left. It is how diffusing or basically Stable Diffusion is working. So it starts from a complete noise image on the right, and step by step, it moves it generates the images towards the direction of the prompt. So you have a prompt, which is, for example, residential building, and it would be encoded as a vector. Here I said it's a prompt embedding. Usually using Blip for Stable Diffusion, and for the prompt embedding direction, the diffusing now will have a clear direction. So it's gradually become concrete and visual. So that is how a image generation process is completed. So what about the caption? No, the training process is another way around. So each training steps start with a training image and a caption. So a caption is a text that used to describe the content of the image. So here is the residential building from the left, for example. So there's a difference, a clear difference between the training image and a complete noise image. And the difference will be matched to the caption embedding, so that whenever you input a caption like residential building, then the backward generation process will be matched to from the noise image to the training image. But for all this process, for all the training process and diffusing process, which is the generation process, we find something is the text is not expressive enough to depict a picture. We can annotate our images as detailed as we could. For example, if we have a data set from the right, all of these images looks have something in common and have some different structure or elements in each of them. We could just caption them as building or concrete building, or house made of concrete, or we could see some of them, or most of them are villa. So we say that it's a modern villa made of concrete, or we could even go into more details, such as the environments, the lighting conditions, the surroundings, all of the stuff, the landscape. But we cannot avoid some overlapped words in our caption because it's just not possible. So because it's impossible to fully caption an image and tell the difference from one caption to another, it's very common that some of these training images have the same captions as each other. At least some part of the captions overlaps. So going back to our initial question, why LoRa if we already have checkpoints? The short answer is checkpoints is better at generalization, while LoRa usually has higher expressiveness. That said, usually a checkpoint is a checkpoint that is trained by millions of images with millions of captions is going to be the mean of the data set, and it cannot generate same concrete buildings as the one trained in the data set. So for the images on the left, it's generated by Stable Diffusion 1.5. You could see concrete and maybe a building, but it's definitely not a concrete building that we are looking for. But for a LoRa, like the data set that we used to train the LoRa, we can change the understanding of the base model. So it recognizes concrete buildings as these decent buildings from our training data sets. So if you want to emphasize some attributes of the desired images, like better image quality, some modern design style, or the landscape around the buildings to make it less boring. So we need, then we need LoRa. So what is a good LoRa? From my perspective, it should have 5 attributes. First, it should do its own job. So if it is an architecture design style LoRa, then we expect to see that design style is applied to our generated images. And second, it should show this ability at different domain. For example, we have an Apple LoRa and applies it to an architecture and use it to generate a architecture, then we should see a building. We expect to see a building in the shape of an apple or has the color of the apple, something like that. And generate high quality images. That's a little bit subjective. We want the LoRa's to generate good images with better lighting conditions, more details, and other attributes our training images share. But as I said, it's kind of subjective, but maybe it's measurable. And also, we often hope our LoRa to work with multiple checkpoints because every checkpoint has its own focus that's suited for a specific focus. For example, we have a checkpoint for portrait. We can also use the handmade LoRa in it and see if we could change a human portrait to become somewhat handmade model-like to see whether it works with the different checkpoints. And there's another maybe not very important aspect, but I could see that some of the most popular LoRa's are among these this type. So it solves a general problem. For example, there are LoRa's for creating more details. So if you use that, the images you created is just have more details in it. For example, more landscapes or trees, or the texture of the building is better or something like that, or there are more detailed windows or handrails and other stuffs. So these general purpose LoRa's are very useful and very popular. I will take one of my LoRa as an example. So this one is LoRa for creating perspective session drawing. So you can see that if I generate images with some very basic prompts like building, so it generates these 4 images. Does it did his job? Seems to. So has it shown ability to fit with another, to be fit in another domain? For example, I try to generate a pineapple with this LoRa, then you could see that even though there's some white and black color scheme applied to the image generated, it's not a very harmonious merge. So it's not quite. Does it generate high quality images? As I said, it's very subjective. You see, some of them looks quite reasonable, and maybe we can say that it's high quality, but some of them has back structures and obscure layouts. So I would say it depends. So does this LoRa work with different checkpoints? For example, I use this with another checkpoint to generate a spaceship. We can see that it is still the black and white color scheme is working, but not quite the perspective section drawing like. So it did look like a blueprint or something, but it's not what I wanted. So it's yup. So with all this perspective to evaluate a LoRa, a very important lesson that we learned that it's hard for people to have common understanding of how good or bad a model is. So we need to set some matrix or workflows to evaluate our LoRa models better. For example, for a LoRa models, if we want to evaluate whether it has done its job, which means that the model is generating the things that you want. You could have your training images to try to caption your training images and compare it with the generated images. So these captions were generated with some auto captioner using Blip, so that I put our training images into the captioner and it returns this description. And I also put the generated images into the captioner and it used a similar caption. So maybe we can calculate, we can come up with a matrix that describe how similar these two, so the training data set and the generated data set, to measure their differences and comes up with so for those who have used LookX to create a LoRa, you may have seen the automated prompt test with different prompt and weight. So basically, it's very common in LoRa evaluation. So we have some preset prompt and of course a fixed base model, and we try to see that if we apply a trained LoRa to it, how would it change the image generation process. So for example, we have some commercial building, some night building, some mountain images and gallery images, and we have a LoRa for it, and we could just try to see if it just affects, it just changes the things that we wanted to change and leave the other things alone. For example, this LoRa focuses on creating a villa by the sea. So you could see that with higher weights, it's generally changing the generation to something like a villa by the sea. So But if we have an apple here, and or other stuff that's irrelevant to a a building or house, then it should be the same. So that's the purpose. And for high quality images, we actually have some a lot of research for that. They have something called the aesthetic score. So basically, it's an algorithm or a model to calculate maybe like how many pixels, different color pixels in a patch or something, or there's some very high quality images trained and low quality images trained with human annotations and train a model and to evaluate to predict a score for the image quality. So that's another way to quantify the evaluation. So for evaluating whether a LoRa works with different checkpoints, so it's basically testing its generalization ability, and probably it's not a score. So we can't comes up with a score to describe whether it goes well with different models. So if we have the same info text and we put it into model one and we have some results of the comparison of the image with or without a LoRa, and this and also apply it to another model and see if it does the same work. But it's very hard to comes up with a score or a number to describe the differences. So maybe for this part, it's better to just create a workflow, maybe writing a Python script to have some baseline model and compare the results. So for the final assignment, I think there's a part of you to decide your own, to design a way to evaluate a LoRa model. So there's some tips that I can give to you. So to design a system to for LoRa evaluation, there are some rules such as that the evaluation could be automated or semi-automated, which means that you could have human involved, like human to judge whether it's good or not, but you can't like have a lot of work to do, a lot of manual generation or testing to do. So you have to put it into a automated way. Or you can just come up with a number. So you have a score for the LoRa or different aspect of the LoRa. And second, it's better to have the LoRa measurable. So a LoRa could have different attributes, and each of them could be measured by some matrix, but the matrix is should be designed. And also, you could come up with a lot of different additional evaluation ideas, and they are very welcomed. So maybe you could start thinking about the LoRa evaluation system from now. So So basically, this is what I've got today, and I will stay for your questions. So